In this video, we are going to review scientific notation. I have three examples here. We are going to turn these three numbers into proper scientific notation. Now, I am going to do it with while maintaining significant figures, but on most quizzes and tests, I'm not going to require that. I'm only going to test significant figures when I specifically test significant figures, but I am going to show you the right way to do this from the very beginning, just in case. So the first thing is we remove numbers that are not significant figures. So significant figures, there's a video on that. If you don't know what they are, you need to go back and watch that first. But I'm going to get rid of these zeros and these zeros. I am going to keep the zeros in the middle always. That's never an exception. And these zeros on the end are significant figures based off the present absent rule. You should know what that means. So those are the zeros that I get rid of. Now I'm going to move the decimal to make a single digit number. So what that means is the decimal normally, if it's not written in the number, would be at the end. So in these two cases, it would be here. And in this number, it's smaller than 1, so they wrote it in for you. It's right there. So that one's not hard. Now I'm going to move it to behind the first non-zero number. So it's going to be 5.091, 1.0062, and 2.500. Then I'm going to multiply these numbers by 10. So I'll rewrite them. And then we're going to figure out our exponent. Now, a couple rules. If the exponent is positive, that means we want to move this decimal to the right. And if the exponent is negative, that means we would want to move that decimal to the left. So what we're going to do is we're going to figure out how many spots we have to move it to get it back to its original location. The original locations were where they were originally. So in this number, I put it behind behind the 5. So I would have to move it 1, 2, 3, and then 4, 5, 6, 7, 8 spaces to the right to get it back to there. So this becomes times 10 to the 8. This number, this one, I put it here, and I need to move it 1, 2, 3, 4, 5, 6 to the right to get it back to its original location. So times 10 to the 6. Those numbers are both positive. If you put plus in front of it, it wouldn't be a problem. And then last but not least, I put the decimal there, and it needs to move 1, 2, 3, 4, 5, 6 to the left. So that's to the negative 6. If the exponent is negative, you have to write the negative sign. If the exponent is positive, you do not have to write the plus sign, but it's not a bad habit to get into. That way you don't make mistakes on that. Now, these problems, what you're going to do here is you're going to take them and put them into scientific notation. And then these problems here, you're going to take them out of scientific notation. That's actually much easier. I'm going to do a couple on this video with you just so you can have an idea. And then the answer key will be available if you need it or if you're absent. So the first thing we do is we get rid of zeros that are not significant figures. So those are the ones we want to get rid of. So we get rid of all those. Then we assume the original decimal was there, and in this it's written in, so we don't have to worry about it. Then we're going to figure out, we would put it behind the first non-zero number, which in that case is those locations, and then we figure out how many we have to move it. So this is going to be 1.25 times 10 to the 1, 2, 3, 4, 5 to the right, so it's times 10 to the positive 5. This one, I would have to move it 1, 2, 3, 4, 5, 6, 7 to the right, so it's going to be 3.60045 times 10 to the 7. And then this last one would be 5.6 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, ninth power. Now, a very common problem that I get that students typically have an issue with is these next two. They look like they should be the same answer, but because of the present absent rule, those zeros are not significant, so we get rid of them. So your answer here just becomes 1 point. Not even 1.0, because that would tell me that 0 is significant. Just 1 dot times 10, and then we put it here, and it's going to go 1, 2, 3, 4, 5, 6, 7 to the right. So it's 1 times 10 to the 7, or 1 point times 10 to the 7. The decimal point actually isn't really necessary there, but you can put it in just to keep the format. Now this next problem, the decimal is there, and so therefore it does matter. So my answer ends up being 1 point. So I have the same amount of zeros, and it's still times 10 to the 7. So the difference here is the present absent rule. Sometimes we get rid of zeros if they're not significant figures. Sometimes we keep them. I'll do a few more over here, and then that'll be it. So this is going to be 1.5 times 10, 2.56. And then we just have to figure out how many we move them. So here we went 1, 2, 3, 4 to the left. Here we moved it 1, 2 to the left. Here we moved it 1, 6 to the left. The common question, or the ones that students usually have a large problem with, would be this one right here. The reason being, those two zeros are not significant figures, so we get rid of them, and then those are significant figures, so we keep them. So your answer here would be 1 point. And in this case, it's going to be 1, 2, 3 to the left. So that hopefully explains this. If you need to go back and look at the present absent rule sheet again, or video again, definitely do that on counting significant figures. And then for taking them out of scientific notation, I'm just going to do one of each because they're super easy. This says times 10 to the positive 6, so I'm just going to take that decimal and move it 6 to the right. So it's going to be 6, 2, 9, 1, and then so that would, if I moved it 3, if I moved it all the way to the end of the number, it would be 3. I need to move it 3 more to make 6, so I'm just going to add zeros in, and there's the decimal. Now, here's the trick with this. If we're using the true present absent rule, this answer would not have a decimal point on it. It would look like this. The reason being is because these zeros are not significant. The reason I know they're not significant are they were removed from the number. So therefore, if I put the decimal in, then I would be saying that they are significant. And so I have to, in this case, not put a decimal in that number. The next one, we'll do one of these. This one, we take it and we move it 4 to the left. So it was here behind the 3, and then I moved it to the other side of the 3. That's 1, and then 2, 3, 4. Decimal goes there. Just be aware, moving from one side of the 3 to the other side of the 3 counts as one of your moves. That's a very common mistake. And then the last thing I'll do is just one of these. I'll do these two down here because this tends to throw people off. They look like they're the same problem, but basically these zeros are significant. The fact that they're removing them here says that they're not. So my answer here would be, this one is 1200 without a decimal, and this one would be 1200 with a decimal. So now, like I said, on tests, I am not going to worry about the present absent rule. So I will basically not distinguish between these two problems. The same thing up here. I wouldn't distinguish between these two on a test, but I am showing you the full version of this in case you are going to be taking like an SAT 2 or something like that. Then you would actually need to know this information.